So, if you work with data, you know the game. You've got this mountain of raw numbers, and your job is to turn it into a beautiful, clean, insightful dashboard. Well, in this explainer, we're going to unlock the essential SQL commands that professional BI analysts use to do exactly that, every single that. But hang on, here's a fair question. You've got these incredible modern BI tools with all their fancy drag and drop features. They seem so smart. So why on earth would you still need to learn something like SQL? It almost feels like a step backward, right? Well, there's a huge reason why this is still a non-negotiable skill, and it really all boils down to one thing. And that one thing is speed. It is all about performance. Imagine you connect your dashboard directly to a massive database table with, say, 10 million rows. That dashboard is going to crawl. It'll be painfully slow. The professional move is to write a SQL query that creates a custom view, which is just a fancy name for a smaller, pre-filtered, pre-summarized table with only the 1,000 rows you actually need. You connect your dashboard to that, and boom, it runs lightning fast. So, let's start at square one. Before you can build anything fancy, you just have to know how to ask the database for information. This is the absolute foundation, and it all starts with a select statement. The simplest question you can ask is, hey, just show me everything. In SQL, that looks just like this. Select star from player. Now, that little asterisk, the star, is basically a wildcard that means all columns. You're telling the database to grab every single piece of information from our player table. And for our examples, we're going to be playing around with a cool database full of stats from the FIFA video game. Okay, but let's be real. Asking for everything is almost never a good idea. It's just not efficient. A much better practice is to be specific. Instead of that star, you just list out the exact columns you want, separated by commas. This way, the database does way less work, and you only get the data you actually care about for your analysis. Now, here's a pro tip. Database columns often have kind of clunky technical names like player_name. To make your final report look polished, you can rename them on the fly using the as keyword. So, player_name as full name. See that? This simple trick, called an alias, makes the final output so much cleaner and easier for anyone to read. All right, so we've picked out the columns we want. Great. But what about all the rows? We probably don't need every single player in the entire database. So the next logical step is to filter down to just the group we're interested in. And that brings us to our second building block. The where clause is your best friend for filtering. Honestly, think of it like a really strict bouncer at a club. It stands at the door to your data and only lets through the rows that meet the specific condition you give it. So if you only wanted to see players who weigh exactly 190 pounds, the where clause is how you do it. And this is where it gets really powerful, because you can get incredibly specific by stacking conditions. If you use and, you could find players who are both heavier than 190 pounds and taller than 190 centimeters. But if you used or, you could find players that meet either one of those conditions. These little words give you such precise control over the data you pull. Okay, now we're getting into one of the most powerful things SQL can do. In the real world, data is messy. It's almost never sitting in one perfect, convenient table. Nope, it's usually spread out across a bunch of different tables, and a huge part of an analyst's job is knowing how to stitch them together. This quote from our source material just nails the classic problem perfectly. We want to see a player's name and their performance ratings side by side. But what do you do when the names are in one table and the ratings are in a completely different one? So, check this out. Here's our first piece of the puzzle, the player table. It's got the player's name, but pay close attention to that player API ID column. Think of it like a unique serial number for each player. Just keep that column in your head for a second. And here's the second piece, the player attributes table. It's got the ratings, but no names. And this is the key to everything, it also has that player API ID. That shared ID is the bridge. It's the common thread that's going to let us connect these two tables together. We connect them using what's called an inner join. This command is like telling the database, hey, look at the player_API ID in both of these tables. Wherever you find a perfect match, I want you to stitch those two rows together into one. The result is this brand new virtual table that has columns from both, finally giving us the player's name right next to their rating. Now, as your queries get longer with joins and things, they can start to look pretty messy. So here's another pro tip, use table aliases. Just like we did with columns, you can give your tables short nicknames. Here, we're calling player attributes A and player B. Just look at the difference. The query on the right is so much cleaner and easier to read. This is absolutely essential for writing professional code that you or someone else can understand later. Okay, so we've selected our data, we've filtered it, we've joined it together. We're almost there. Now it's time for the final and maybe the most important step for business intelligence, turning all those individual rows into actual meaningful insights. So here's the next challenge. Our joint data is great, but it has tons of rating entries for each player from different points in time. A long list of thousands of ratings isn't really an insight, is it? The real business question is something like, what is each player's average overall rating? And the answer to that question is the group by clause. This thing is an absolute powerhouse for BI and SQL. It takes all the rows that belong to a single player, for example, and it collapses them down, letting you run a calculation on the whole group, like getting a total sum, a count of entries, or, in our case, the average. This slide shows it perfectly. It's like you take all the individual rating rows for one player, you funnel them into an aggregate function like AVG, and then group by player underscore name is what tells the database, okay, do that calculation for this player, and when you see a new player's name, start a new group and a new calculation. It rolls everything up into one meaningful number per player. And the result is, well, it's pretty dramatic. Look at this. We took over 11,000 messy individual records and transformed them into a clean, simple, insightful list of just 26 players and their average scores. This right here is the whole point of business intelligence. You're reducing all the complexity to find the signal in the noise. But what if we only want to see the absolute best players? You actually can't use where to filter a result that's already been grouped and averaged. For that, SQL has a special partner to group by, the having clause. Having works just like where, but it's specifically designed to filter your data after the group by calculation is all done. So here, we're asking to only see the groups of players whose average rating is greater than 85. And now we put it all together. Every single one of these building blocks, the selecting, the filtering, the joining, and the grouping, they all combine to form one final powerful query. This is the exact query you would save as that view we talked about way back at the beginning. You know, this quote really sums up the journey. We started with a simple select star command, and by adding just one concept at a time, we've built a pretty sophisticated query that delivers a clean, efficient, and super insightful data set. The perfect fuel for a fast, responsive dashboard. Because at the end of the day, that's what SQL is. It's the language you use to have a conversation with your data. The tools we've just walked through, they're the grammar and the vocabulary. They're what empower you to move beyond just looking at data and to start asking the deep, complex questions that uncover real value.